Hey learners, back again with another video. Today we'll talk about one topic that will be our percentage composition. How can we determine the percentage of constituents of a given compound? Suppose we are having a sample compound that is A, and I want to know what is the percentage of the constituent particles are those which it is made up of. A is made up of a constituent particle, two particles, that is A and B, and I want to determine the percentage of A as well as B. So for that we require percentage composition determination. Okay, got it? And it is required, or we can say it is very helpful in determining the purity of a compound. Suppose I am purchasing a gold article and I want to know what is the percentage of gold in that article. We are having the article C and I want to know whether it is pure or not. So with the help of percentage composition we can determine that it carries how much percentage of gold element in that. Got it? So why it is required and how we can calculate the percentage composition. Let's see what is the percentage composition determination. To understand this, we'll take an example here. I am taking here water molecule. Water is made up of hydrogen as well as oxygen. Hydrogen has atomic number 1, oxygen has atomic number 16. Sorry, not atomic number, atomic mass. Atomic number is 8, atomic mass is 16. So first we will calculate the molecular mass of water. That will be, we are having 2 hydrogen here, so 2 into 1 plus 1 oxygen here, 1 into 16. So molar mass will be 18 for water molecule. Now we got the molecular mass. So to determine the percentage composition we require a formula that will be mass percentage of an element. Percentage of mass percent we can say. That is equal to mass of that element in compound divided by molar mass of that compound. Suppose we are having a compound, we have to take mass of that particular element which it is made up of. If it is made up of 2, then we'll calculate for 2, then we'll see what is the percentage. If it is made up of 3, then we'll calculate molecular mass percentage of each element. Then we'll determine the percentage of that element in that given compound multiplied by 100. Okay. So let's see what will be the mass percent of water molecule. Here we have molar mass of water. We have already calculated, that is 18. So first we will determine mass percentage of hydrogen. According to formula, we are having number of hydrogen 2 and atomic mass is equal to 1 divided by molecular mass of that compound, total compound which it is made up of. This is a compound here. Here we are talking about hydrogen here. See the difference between 2? Here I have written 1 into 2. 2 hydrogen are there. 18 into 100. So after calculation, what will be the percentage? That will be 11.18, or we can say 11%. If we'll take the 18.0 to 1.008, then we'll get the 11.18. So I am writing it here, only 11% is for hydrogen. That means I can say that percentage of hydrogen in water molecule is 11%. So next is percentage mass of oxygen. Here we are having single oxygen, so 1 into 16 divided by 18 into 100. That will be equal to 88.79%. Okay, if you will add both, you will get 100%. If it is coming 100%, that means you have done calculation accurately. Because water molecule, it is 100%. We have to calculate what percentage is hydrogen and what percentage is oxygen. So here we have got mass percent of hydrogen that is present in water molecule is 11% and oxygen is 88.79%. Okay, got it? So this is the percentage composition. It is very easy. Let's take another example. Okay. Here we are having a question here. What is the percentage composition of carbon, hydrogen and oxygen in ethanol? First, what is ethanol? It is C2H5OH. Ethanol. Alcoholic group is there, 8th. Number of carbon 2. AN stands for single bond. So we are having here C2H5OH. So we have to calculate percentage of carbon, percentage of hydrogen and percentage of oxygen. Here we are having number of carbon 2, number of hydrogen 6 and number of oxygen 1. 6, hydrogen 6, remember this. Okay, first we have to calculate the molecular mass. So what will be the molecular mass? 2 into 12 for carbon plus 5 plus 1, 6 hydrogen are there. 1 into 6 plus 1 oxygen is here plus 16. So what will be the number here? 46.0. We can say 46 gram here. Okay. So we have got the molecular mass of ethanol. After that, we are going to calculate mass percent of carbon, hydrogen and oxygen. So here we are having hydrogen, carbon and oxygen. Okay, first mass percent, we are having number of hydrogen 6 into 1 divided by 46 into 100. Number of carbon 2 into 12 divided by 46 into 100. Oxygen 1 into 16 divided by 46 into 100. Okay, here we are having mass percent. They are now you can see properly. So here we are having hydrogen. After calculation, we are getting it 6 into this is 46, 13%. You have to calculate in decimal so that you can get the 100% answer. 13.13. And carbon we are having 52.14%. And oxygen we are having 34.73%. If you will add all these, it will come 100%. If it is 100%, then your answer is correct. You have calculated it very well. If it is not 100%, then there is some error in calculation. Do it again. So this is all about percentage composition. It is very important to determine the purity of any sample compound. We want to know the percentage. Suppose we are using utensils nowadays of alloys, and I want to know that it is made up of what percentage of nickel is present, what percentage of copper is present, what percentage of iron is present in that. So this percentage composition is helpful in determining the percentage of a particular element in any alloys, any sample, any compound. Okay, this is all about the percentage composition. Don't forget to like and subscribe it. Thank you for watching the video.